Now, one of the cool and unique things about CDI is we have representation from drive manufacturers, we have the heavy consumers, and then we have like ITAD folks, and then we have like the advanced recycling folks that are also members. And so we have really great representation of this supply chain that we're going to be able to have a discussion with. So we'll be able to kind of get each unique perspective discussed today. And so that's what we're looking to really highlight. So without further ado, I'd like to introduce our subject matter experts. We have Louis Kotsakis from Microsoft. We have Rob Lawson-Shanks from Molg. And then we have Matt Lipscomb from Alta Resource Technologies.
Yeah, of course. Thank you, Parker. So Louis Kotsakis, Microsoft, 14, I think it's 14 years now. And the last many years, feels like 20, I've been working in, end of life, decommissioned hardware. Okay. And the last 2 years, 3 years, focusing, specializing in data bearing device dispositioning. Okay.
Excellent. Rob?
Yeah, Rob Lawson-Shanks, CEO, co-founder of Molg. We're based in Northern Virginia, right here in Data Center Alley. We build robotic and automation systems for server processing, as well as all the sub-components of those. So we build robot cells that take apart servers, and then building additional variants that go deeper into high-precision disassembly of hard disk drives.
Thank you. Matt?
Hi, my name is Matt Lipscomb. I'm the president and CSO of Alta Resource Technologies. So we have a technology that separates rare earth elements into individual purified rare earths. So we actually able to do interlanthanide separations. So for example, separating the heavies from the lights in a single pass on a column. And the reason this is important is this is sort of the final separation step that's needed to actually get to fungible products. So it's a process that's efficient, that's scalable, and that can actually be deployed in the US and other Western nations.
Excellent. Thank you. All right. So our first question, why do you think the retrieval of rare earth elements is important for the industry over the coming 2 to 5 years?
Yeah, so let me take a crack at that one, Parker. Okay, from my opinion and viewpoint, I mean, if everybody's been reading the headlines in the news, there aren't very many mines on the planet that produce rare earths, and the amount of money to build a mine, the infrastructure can take 8 years, many years to build it out. We have two in the United States, from my understanding, one in California that's active, and they're restarting all the rare earth element extraction. And then believe there's one in Texas that is, a deposit has been found, but they have not started doing any, mining from that location. So why is it important? We have all this attention on energy, wind energy, alternative energy, electric vehicles. There's a lot of consumption and requirements of rare earth elements associated with it. And the United States administration, going back and forth with the countries that have the rare earth elements, we have to come up with alternative processes to recover what we consume. Okay.
Yeah. Matt, what's your perspective on this?
Yeah, so I would echo and add to what Louis shared. I think the data we've seen is that from a mining perspective, something like 85% of the global capacity is currently located in China. But the other thing to remember about the rare earths is it's not just the mining, it's also the processing. So once you identify the ore, you actually have to process that to get it to a purified rare earth oxide. And more than 90% of all the processing occurs in China right now. And there's a variety of reasons for that. So not only is it advantageous to, reclaim the material that's already domestically in our hands, for example, in all these materials that we're talking about, but then you got to have a way to truly separate it, retrieve it, process it, get it back to a fungible product. So I think that's really critical. And then the other bit I would add is if you look at the specifics, so the next level of detail, so Luis is right, there are very, very limited opportunities in the US from a mining perspective. But if you look specifically at the heavies, there is some minor presence of heavy rare earths in those mines, but generally from a domestic resource on a mining or an ore body type process, the heavy rare earths such as dysprosium, which is critical for the high performance applications that we're talking about, the best source of those is actually existing magnets. So while there is some small presence in some of those mines, the best that's available is actually the magnets that we have. So it makes a lot of sense to capture, reclaim, concentrate, and convert those back into usable materials.
Oh, great. Yeah. So when you're talking about these magnets, I mean, is it I mean, the majority on this call are from a specific vertical in high tech computing, but are magnets found elsewhere?
They are. So if you look at the applications for high performance magnets, I think most of this audience is probably familiar with the hard disk drives and the magnets on the drives, right? But they're also widely deployed in things like electric vehicle motors, wind turbine motors, MRI machines, and then there's actually quite a few applications in defense tech as well. So that's part of the reason why the federal government is obviously interested. It truly is a security issue as well.
Yeah. So it's quite interesting, right? That that we're seeing this topic discussed in the headlines, but all these other industries also have large deposits of REE in the machines that they already have. Why do you think Microsoft and WD are getting so much press on this topic versus some of the other folks that might have magnets to harvest or to mine? Any thoughts on that?
I mean, from our side, we made a concerted effort to make a public announcement. Okay, so I partnered with many people that work in sustainability here at Microsoft, and the counterparts that I worked with in Western Digital had sustainability titles, and we wanted to get an announcement out on Earth Day around that time frame. So I think the timing just aligned with everything that was going on. I mean, and even from the initiation of this project, we started 3 years ago with a hackathon project that got attention internally from some sustainability folks. And then it got handed over to me to operationalize it and bring it to life. So your question was, why are we getting so much press? I think it was just, timing, that it got publicized, we amplified it, and then it got picked up by other media sources and repeated, around the world. So
yeah. And yeah, Rob, yeah, please.
Just to double down on it, I think it's just also a really good use case in that there's already really strong collection processes, right? When we think about circularity, that reverse logistics is such a big challenge across the space. But when you look at ITAD, data bearing devices, HDDs, these things are already being processed in some form or another. Unfortunately, it's quite destructive, as we all know. But in that lies a massive opportunity to take a material that has increasingly high value, increasing need for resiliency, domestic capabilities, both commercially and kind of from a national interest. And so it's just a great use case when we're all looking for sustainability, circularity, where it both makes kind of environmental, but also economic and kind of national interest sense.
Yeah, and to add on, I think, you mentioned about, being at the end of life, right? Reverse supply chain, being at a hyperscaler. There's not a lot of attention to bring this to life, for our, cloud business. And I'm working on magnets to put back into other products. So it's doable. We did it, it's happening and we're scaling right now. So
yeah, I think you're leading the charge, right? Like
Yeah.
the tip of the spear with this initiative and almost setting the tone for some of the other industries that might not have that spotlight on them, like a big hyperscaler would.
Yeah, I mean, it was one idea generation after another. I mean, we failed at our first attempt to recover the magnets from the HDDs. Okay, but we pivoted quickly and we built two channels. I mean, we're going to be representatives, my teammates are going to be going to Molg next week. Okay, we're just continue building, these partnerships and relationships. I mean, the one channel is the recycling channel that everybody saw that, was in the publications. And the other one is disassembling the HDDs. So now I can capture the magnets directly and send them to the downstream recyclers that can process the rare earth elements, and I'm not mixing it with other shredded material. So we're trying to optimize the process. I just can't handle the same volume of shredding versus the disassembly. So,
Okay. Well, maybe, going off of that, I mean, what do you think the near term future of REE recovery is going to be, say, in the next 12 to 18 months? What's that going to look like for the industry as a whole?
I've been speaking to, other, peers of mine at the other hyperscalers. There is attention to this. Okay. And are they disclosing, where they are, or are they still in PowerPoint talking about this, trying to operationalize it? Okay, that's the difference. But there is attention to it, and I know from us, this is just continuing to build, right? Like everybody wants to do what I did, but make it better. Okay, is the way I'm looking at it. So there is internal attention here. So I mean, as long as it's continued in the media, I mean, it's going to continue to get more attention. But as far as the collection of the rare earth, I mean, from our standpoint here as hyperscalers, we got to remember our consumption, I think, is a lot lower than the electric vehicle manufacturers or the defense industry. I think there's going to be, to answer your question, Parker, I think it's going to continue to grow and have attention, and we're going to either grow each of us separately, or there's going to be a consolidation of efforts somewhere downstream. Okay.
Yeah. I mean, Rob, what are your thoughts on that?
Yeah, absolutely. I mean, I think it's a maturing of this kind of nascent kind of phase that we're in right now. There's maturing across all of it. Microsoft's doing some fantastic work. We're looking to be an enabler between upstream and downstream partners, and how do we take things apart? What level do we need to take them apart? Where's the right amount of value add in a process where the Alters of the world and others can extract the most amount of value, really reduce kind of their overhead of pre-processing, and really what kind of data volumes economics need to be exchanged between all these partners. And then for us, another side of our business is we use some of our same things that power our robots to actually go and design next generation versions. We do this in electronics, we do it in other forms, where we're designing the next generation of product to be more conducive to this. But I think there's a big opportunity in hard disk drives as well. We're seeing a lot of transition in that baseline technology. There's benefits and there's general standardization across SATA, and most of the things look from a high level the same. But we're already dealing with helium and different types of welding and hammer and mammer and glass platter, and we see that kind of across the board of how those things impact the different various kind of, I would say, post-use cases. And so the more that we can work kind of collectively together to optimize as well as build out the scale and capacity, I think it again will drive better economics and certainly that environmental impact, and was building some resiliency within the supply chain.
Yeah. And Matt, what do you think the outlook for the next year and a half will be?
So I think what you're seeing is an evolution of the factors that are driving this. So if you kind of go back in time a handful of years, the primary drivers around end of life for data centers were really data security, right? And then you had a few leaders in the space like the Microsofts who really brought a sustainability angle, right? And what you're seeing in real time is that in addition to those factors, now you have a real supply chain. Can we get these materials, right? So it's just adding another factor that's proving the importance of being able to capture, reclaim, and reuse the rare earths. And so it's one of those very fortunate scenarios where not only does the sustainability, it's good for the world kind of thing, but it's also a good for business type of thing, right? So companies are moving upstream in their supply chain to make sure, or perhaps downstream, or making it more circular, right? To make sure that we can get the materials that we need domestically without having to worry about kind of the events that are happening geopolitically around the world. And so I think all of those factors are only going to accelerate in the next year, 18 months. And I think I think you're likely to see more types of these types of collaborations, more examples of these types of collaborations where you're putting together all the pieces of the puzzle to bring it to a reality, right? I think, Luis has already led a really good example of this, right? And with Rob and Molg's contribution, and Alta coming online, I think you're going to see it's really the birth of a new supply chain looking at end of life for the magnets, collection and concentration. So, getting the magnets into a form that can then be separated and then, productized again into fungible rare earths such that, the hyperscalers can use them again in the products that they need. So it'll probably be a bumpy road because building new supply chains turns out that's not easy. But I think the factors are aligning, the drivers are aligning, which is a good place to be. So.
Yeah, Lou?
And I'll just add that, with the publicity of this, it also drives more money into it, right? I mean, Matt and I, we share share investors, there's money coming into this to do that. And the great work that, Louise and team are doing in making this a more well-known issue, it drives kind of the capital into this so that we can really build the scale that we need to do this for real.
Yeah, the investment piece, our climate innovation fund invests in the companies, and that's an enabler for me, right? To find partners downstream that want to make this successful. The other part, completing the circular supply chain is now that we're scaling and we can collect the, rare earth oxides from our decommissioned HDDs, and the magnets. What do I do with that now? How do I get that back into magnets, future magnet manufacturing, and then back into our HDDs, right? Yep. What am I going to do with this material? So I still have to work upstream to change how that, tier 2, tier 3 suppliers operate. So.
Well, I mean, hey, look, you got this far, Louis, so you can pull that part of it off too. Well, okay. So I mean, we've identified. I mean, this is not easy, right? There's a lot of players that have to work together for this to go smooth. I mean, what other obstacles are there? Like, what are the barriers for entry? How do we make this, an established industry? Not just, an emerging one, but what obstacles do you see and can you identify for the group? Rob, you want to go ahead and take that one?
Yeah, absolutely. So I think, it's amazing the new technology that this group is doing and in making these new types of hard drives, and we're progressing the technology. With that, though, I think we still a lot of opportunity for design optimization for kind of full life cycle, processing. The novelty sometimes is not necessary, and we look at all the different types of hard drives, and I think there could be further standardization, and this is something that from a design perspective, that won't necessarily make an individual product better than one another. I think we've done great standardization. I think it could be progressed from the design side. And then, I think it's also about learning from each other and what we really need again. So what is the best way to deliver a kind of scaled material, to the downstream or upstream partner? And how do we share that feedback in forums like this, where we can collectively move, the different aspects of this forward? So I guess, more collaboration across, the community. And then, ultimately it's going to be continued drive investment to get the scale where we get the economies of scale, and then can continue to drive the economics of this so that we can carry along all the other missions that are important to this effort.
Okay, great. Just to kind of add, a lot of the responses we received from the survey that we sent out had identified the number one barrier being cost, cost to build the infrastructure to retrieve these elements. Could you maybe, chat about that a little bit? I mean, how can we overcome some of that?
Yeah, so for sure, for us, part of our cost structure is, we typically charge per device that we process, just kind of in a flat fee. But the more value our, upstream kind of hyperscale customers can get from that material, the more that value that Altas and can generate from that, turn that back into the procurement, the more that we can preserve we're also interested, we do a lot of reuse, but it's very, very nascent. So the less additional processing that we can do for hard disk drives, the better. But I think there's more collaboration, about what does it mean to take a PCBA off of a hard drive and requalify that for reuse. And then additionally, what are opportunities to keep that drive running longer without it having to go through, extensive processing? And I know there's many conversations there about crypto keys and the next kind of form of this. But ultimately, I think it is how can we all make this individual material more valuable? The market is doing that to an extent, that will be either, tariff derived or geopolitically, derived. But we're seeing that trend, which is good for building this, economic model to make this scaled process. But ultimately, I think it takes, some transparency, some kind of working together, not trying to keep all the secret source to one another. I think there's many, many ways to win, and how do we win across the value chain? So no one party is kind of eating the burden on the full cost of doing this. There's, amazing investment out of, Louise and team and, leading the charge, showing what's possible. But how do we build on that to the point that this just becomes the default way of doing business?
Okay, great. Matt, any comments on this topic of obstacles?
Yeah, so I think echoing the comments around having enough capital available to get this done. So obviously, anytime you're building a new supply chain, that's going to be incredibly capital intensive. And not just having the money available, but having the right type of capital available, right? So early stage technology companies are well suited towards venture dollars, venture investments. But as you move down the commercial path and begin to scale, right, venture is really no longer the best avenue or the best type of capital to deploy for that. So having some big names like Microsoft around the table, who have not just a financial but a strategic interest in seeing this come to reality, and who are perhaps or hopefully a little more patient than some of the earlier stage VCs. I think there's a real value in having that sort of anchor type of investment. And I think you'll see that. And then I think building on some of Rob's comments, I think you'll also see an evolution in the sort of the strategic relationships amongst all the players. So obviously there's a number of folks around the table who bring pieces of the puzzle that are needed to make this a reality. And as with any time you're building something new, those earliest conversations tend to be more transactional. Oftentimes you're just fighting for your own survival at the beginning. But I think over time you'll see those become a little more strategic. So it'll be less about, how do we maximize an individual piece of the pie versus how do we all work together and grow the pie such that this really has the best chance of coming to reality.
You bring up a good point, and it's actually one of the questions that was raised in the chat. I mean, what's enough drives or what's enough magnets to move the needle? Thanks for the question on that, JM. But where are we at? I mean, what do you guys think? I mean, Matt, do you have a comment on how much is needed? For domestic use or for reuse in a circular scenario like Louis talking about?
So short answer, I think there's plenty available. So I'll be the first to admit that I don't have the latest numbers on how many HDDs are being decommissioned every week. But there's certainly in the order of tens of thousands of drives. And so I think there's enough there to make a real dent in this. But it's going to take a concerted effort to rethink how that end of life commissioning is done in a way that can actually facilitate this, right? And Louis correctly identified a lot of the issues, right? Whether it's aggregation, the cost of disassembly, doing it domestically, the data destruction and certification piece, supply chain, the chain of custody around that. Those are all real issues that have to be solved in a intentional, forward-thinking way. But my understanding, and I think one of the differentiators between, say, an HDD and a hyperscaler type situation versus, say, a electric vehicle motor type thing. So yes, the magnets in an HDD are quite small, obviously, relative to the total package of materials. But there's also the sort of the cycle rate. So in other words, how fast they're coming offline. So at least perhaps some perhaps naive understanding of how fast some of those data centers are cycling and coming to end of life is orders of magnitude faster than, the projected timeline for, say, an EV motor or a wind turbine motor, right?
But yeah, like, for example, I mean, if we know that tens of millions of drives are being destroyed per year, I mean, would a million drives or 2 million drives make a dent in in this initiative for recovering rare earth elements? I mean, would that be a significant amount of elements that are put back into the market? Is that
Let me answer that. I'm
Yeah.
not gonna, I mean, that's what I've been working on these last 2 weeks with all the geopolitical discussions going on. So what I can tell you is, okay, the magnet content and the amount of rare earths, I believe, is higher in the latest HDDs that are being deployed versus the old ones. Okay. So what I'm getting at is the demand is growing for the rare earth elements, but what we're decommissioning, it doesn't match. And then you have loss in your recycling process, right? Okay, so there's that piece. So there's millions of drives being decommissioned. And then, what we're recovering, what we're able to recover versus what is needed, it doesn't match.
So good. Yeah. So there's a big need for it.
Yes.
All right. So let's see. Perhaps what we can do is open it up a bit to the group here. If there's any live questions, Andrew, you have a question or a comment that you'd like to bring out?
Yeah, more or less. First off, I want to thank the panel, right, and for you leading it. The one thing for us to really think about to set the stage in perspective is this tends to be an abyss, here in the U.S. and in the Western countries, because essentially today CDI's goal has always been about reuse of drives, and that is still the primary initiative from a circularity standpoint. But what tends to happen here in the US, because we lack the capabilities, and that's what the panelists are talking about, is once it does go end of life, because of governance, compliance, everything you've heard here, that gets shredded. And that's happening in every hyperscaler. And today, that shred is sold at 55 cents a pound and pretty much just flows over to China. So if we look at supply chain resiliency, the economics, first off, don't pan out today because things are changing. That is a loss leader position, for China, who has to use hundreds and thousands of passes of kerosene ultimately to get the individual rare earths, which is why it's made no economic sense here in the States. This team and kind of what they're doing are putting the pieces together to really create an end-to-end solution, because what Alta is doing in particular does not exist in the US today because of the environmental damaging, and them having a clean process that is also commercially viable allows us to have these discussions, but it still requires that upstream. How do you get and work with the hyperscalers? How do you work with Molg? How do you address the compliance issues? So it's really this innovative collaborative process that has to happen. But again, for context, people are like 55 cents a pound hard drive shed, out of sight, out of mind. And we can talk circularity, and I don't care if you're concerned about supply chain resiliency, national security, or if you're still on ESG circularity. It just is crazy to think that this stuff will hit 3 or 4 different stages and ultimately then get shipped over to China, who gets to process it. So I don't care what your lever is that you're focused on, it just makes sense to keep this here. And to date, if we look at the economics, which everyone's talking about, it hasn't made sense because people are willing to take a loss leader position. Well, that dynamic is going to change. And right now, it's really about the thought leadership that's happening on this call that allows us all to drive this needle forward. So I think it's a great conversation, and I love kind of seeing these organic conversations. That's how we solve it. And the thought leaders like Rob and what you guys are doing with Molg and Luis, you guys actually championed this for several years. There was a lot of foresight there, and now it's just that next level of collaboration. But the biggest part is education, right? Because people just don't know that, like, hard drive shed and out of sight, out of mind. So it's the awareness, and that's the goal of this panel as well.
I think what the question in his chat is about shredding drives at the data center versus offsite, using, leveraging Molg. Yeah, I mean, perhaps is Rob Yeah. Okay. Rob, I mean, do you guys offer, like offsite services, for people that'd be interested, to utilize some of your equipment and in robotics, or are you primarily doing that, on site for customers, or a combination of both?
Yeah, so there's some fantastic developments. Microsoft has their circular centers, doing amazing work there. Some, being co-located very close with their very big campuses. There's drives that don't wipe in the DCU on the decommissioning process that need to be destroyed on site. So some things do get, go through some kind of deeper level processing, physical processing on site, depending on, the sensitivity of that data as well as kind of its initial wipe process. But you do see consolidation at the ITADs, hyperscale owned ITADs. This is where the volume is happening of this work. Our systems are designed to be deployed wherever that material is and where that need is. So we design a small footprint, highly deployable system that can be wherever that material is. But ultimately, we do see this market trend where the majority of, say, our deployed systems are in these consolidated areas where you're going to have your high throughput. And it's going to be more than just specifically hard drives. You start with racks, right? And then racks have the servers have the drives. And it ranges between the different types of racks, but you have individual servers that can have up to 72 or more hard drives in a single server. So we try and be where that is, and we have a whole variety of automation solutions that go from rack to hard drive processing. And it's all about trying to do that as scalably, economically, and kind of with the ability to do the level of processing sortation that adds the most value back in. So again, it's about understanding what our downstream partners need. Do we need to take them off the magnets off the covers? Is there a process agnostic to that? These are all the types of really helpful conversations. And then taking those learnings and then giving them back to the HDD OEMs to say, hey, if we adjust some of these, weld types or, consolidate fastener heads, we could improve our process, reduce the, economic burden of this, and ultimately make this more scalable.
All right, thank you. Yeah, hopefully, Zachary, that answers your question nicely. Thanks, Rob. So, just maybe one last question on, and of course, friends, ask away if there's something that I'm not covering. But how would you experts, how do you think that we, as an organization, CDI, this group of members of varying interest, how can we leverage this organization to promote this portion of the industry? What would you say?
More collaboration. Okay, I think if we collaborate, we have more volume. We mentioned earlier about the volume availability. Okay, cost, right? How can we reduce cost? Well, if we supply our decommissioned equipment to a Molg or a source that can manage and get economies of scale and do this work, that'd be fantastic. I mean, I'm doing half this work in-house. Our disassembly is in-house, right? We're data center operations. Why am I disassembling drives? Okay.
Yeah.
So, I think that's a key one is collaboration, and doing, finding an idea and then executing against it, right? The ideas are easy. We can all come up with ideas. It's the 95% is, getting it operationalized and doing the heavy lifting. If we do more of that, then make a LinkedIn announcement and then gains traction in a life of its own. So.
All right, excellent, great comment. And hopefully that's what after this meeting we'll be able to make some of those announcements, and it'll probably snowball into some potential collaborations on group members. All right. Any other comments, folks? We might wrap it up there then. Thank you all very much for making the time to speak and sharing so much of your process. Really, really appreciate that.